Hi, my name is Nan. I am a PhD student from Eindhoven University of Technology. Roughly a year ago, I was inspired by a friend who is a software developer in a company that develops high-tech embedded systems. He told me that a lot of his time actually goes to analyzing the logs that are generated from their software systems. And it is a tedious activity because the tool they use is not very effective. This gets me thinking about the questions of how developers actually use logs in their practice, what kind of challenges they are facing, and what kind of tools can help them. Today, I'm going to present a study that answers these questions. Nowadays, all kinds of embedded systems are generating logs at runtime. These logs are then collected and used by software developers for their maintenance activities. In the literature, many log analysis tools have been proposed to help developers. However, these tools may not be applicable and effective in industrial setting. For example, an empirical study found that a state-of-the-art log mining technique suffers from scalability issues and cannot provide information that developers need. Therefore, we would like to take a step back. We would like to first understand how the developer use logs in their practice so that we can envision a useful tool for them. In order to envision such tools, we need to first understand in which context the tool will be used. So we first ask what type of logs do developers use and for what purposes do developers analyze logs. We expect such tools can extract the information that developer needs, so we ask what information do developers need from the logs, and finally, what do developers expect from such tools. To answer these questions, we apply semi-structured interview, which allows us to predefine a set of questions and ask follow-up questions during the interview. After the interviews, we then apply qualitative analysis to the transcript that we got from the interviews. We conducted our study at ASML, which is a leading company in developing the machines that can produce chips. We invited 25 developers from metrology and control departments. Those developers are responsible for the software that can control the machine actions and the calibration process. In this presentation, I'm going to cherry pick some main findings. If you are interested in the details, you can check our paper. In total, we identified 18 purposes, and we then further grouped them into 4 categories. 9 of these categories are related to issue analysis. When an issue is found by testing or at customer side, developers need to, for example, localize the problems and figure out who needs to fix the issues. 6 purposes are related to verification and improvement. For example, when a new functionality is implemented, developers need to check if the design has been implemented in the way they expected. And when a customer requests an improvement on system throughput, developers then need to extract the timing information from logs. Software comprehension is another reason to analyze logs, especially when the software document is not very well maintained. Log is also used during test development to see if the errors can be handled correctly. Among all these purposes, issue analysis has been mentioned by all the developers. This is because in the context of a concurrent program, the traditional debugger is not always applicable. As explained by the developers, ASML systems are time constrained with concurrent design. There are multiple processes running concurrently. They communicate with each other at certain points. The introduction of breakpoint to one of the processes will cause the other processes waiting for the response and eventually getting a timeout error. This is called probe effect. That says the introduction of delays may change the behavior of the system that have synchronization logics. After studying the purposes, we then identified 13 kinds of information that developers need from logs. They are further grouped into 5 categories. When an issue occurs, developers need to understand what machine is doing, in which state the software is, and how software components interact with each other. To further understand the code level details, developers need to inspect the data flow, the order of function calls, and for some scenarios, developers also need to inspect the differences between multiple logs and information related to timing performance. In this presentation, I would like to elaborate the information needs about differences between multiple logs, because it has been mentioned by more than 10 developers and it is less studied in the literature. There are several use cases where developers compare logs. One of them is to investigating the root cause of regression and flakiness. When a software regression occurs, they compare the logs generated from the version that passed the test and the version that fails the test. Similarly, when the test outcome for the same versions are inconsistent in different runs, developers compare the logs generated from these runs. Textual comparison tools such as Notepad++ or Beyond Compare is used in practice. Such tools takes two logs as input and compare them side by side, line by line, and highlight the lines that are different. Developers often need to inspect a lot of irrelevant differences in the result. For example, the differences can be caused by the concurrent execution of the systems, the refactoring actions, or the implementation of new features. But in the end, what's really important is the difference that actually points to the issue. In practice, it means developers need to do a lot of pre-processing, removing the false positives. If they do not have sufficient knowledge, they might get a wrong conclusion. This challenge suggests that there is a need for an advanced log comparison tool that can recognize and categorize different kinds of log differences. Log comparison is one of the challenges that we identified. In total, we identified 13 challenges and grouped them into 3 categories related to log quality, the complexity of system, and expertise of software developers. If you are interested in the challenges and the suggestion about tool support, please check our paper. By interviewing 25 developers from ASML, we have learned that logs are very important for issue analysis because of the probe effect in the context of concurrent program. Particularly, developers compare logs for debugging regression and flakiness. Our findings suggest that an advanced log differ is needed. As follow-up studies, we are validating and adjusting our findings at multiple high-tech companies. Furthermore, we are conducting a systematic literature review to identify the research direction for log comparison tools. So this is the introduction of our study. Thanks for listening. Please let me know if you have any questions or comments.
Thank you. Hello, everyone. If you just joined us during the last presentation, my name is Carolyn Seaman, and I am the session chair for this session on observational studies of developers. And I have Nan with me, who was the presenter you just saw, as well as one of her co-authors, Alexander, and they are ready to answer your questions. So please formulate your questions and write them down in the chat. And while you're doing that, I will start us off with one of my questions. I had a curiosity, Nan, about all the information needs that you found and that you tabulated. And you talked a bit about log comparison tools, how log comparison tools meet some of those information needs. But I wondered if, did you find that all the rest of the information needs were unmet, or were there some matches between current tools that do actually fit well into some of the information needs that you found?
Yeah, so we have noticed some, as you mentioned, that one of the information need is the log comparison. So the developers want to know the differences between logs. And we actually also noticed that there were several studies about log differencing. So they tried to compare logs. But the sort of limitation that we identified there is that those tools provide the differences between logs based on the frequency of the differences appear in the log. So they recommend most frequent log differences to the developers. But we also learn from our study that sometimes the most frequently occurring logs differences are not necessarily related to the bugs, or not necessarily related to the information that they need. So that's sort of a gap that we identify in this study. So that's why we think it is important to have a log differences tool that can categorize those differences.
Great, thank you. So we have some questions from the audience. Ivan asks, he says, first of all, thanks for the talk. He says, I'm wondering about the focus on embedded software. How do you think it's similar or different from other contexts where concurrency and log analysis is a problem? For example, concurrent general purpose software or distributed systems.
Yeah, so I think, so indeed, ASML system is time constrained, so it has a concurrent design and make it very difficult for developers to understand. And another thing that we identified there is that ASML system is developed by different engineers, that's including the people from physics, from mechanical engineering, from electrical engineering. So this is a multidiscipline domains. And therefore, we found that developers also mentioned that it's very difficult not just understand the concurrent design, but also understand the information, the concept shown in the logs. So often they need to reappear with the functional developers who are from different backgrounds, and they need to sit together and analyze the logs together. So I think that is different from other domains or other kinds of systems.
Yeah, thank you. Thank you. That's very interesting. I have another question from Thomas, who also says, interesting talk. Thank you. What sorts of interactions might be helpful for developers in working with logs beyond diffs, beyond the differences? For example, visualization, search, filtering. How might some of these vary for different types of tasks?
Actually, I think all the interaction Thomas mentioned here are all relevant, actually all mentioned by our developers. So they need a visualization definitely because there's large amount of information, and they want to get sort of overview of system behavior and how component actually communicate with each other. And at the same time, they also need to have need to search the information that they need from logs, and same for filtering. How might some of these weigh for different types of task? I think for software, for example, for software comprehension, the most useful tool will be visualization, because in this task, a developer try to understand how the system behave and how and the visualization can help them to get an overview of the system behavior. And for some of tasks, for example, if they want to know the code level details for identifying a specific task, then they might want to search the information from the logs.
Okay, thank you. So Ivan wants to follow up a bit on their previous question.
Yeah.
First, Ivan says, thanks. It's interesting how diverse the developers are in this domain. But more broadly, I'm wondering about the right approach that research can take in this domain. For example, there are many tools for log comparison, but the developers in your study used grep and custom tools. Should we build more tools, or maybe existing tools that are more robust or broadly available?
Yeah, I think that's a very interesting questions. I think we need to. I still think that's a new area that's considering log differences to are recently relatively new compared to other types of log analysis tools, and I think we still need to have more empirical evidence and talking to developers to understand what kind of differences and what kind of information they want to get from the comparison. And also, I think that would be a good idea to conduct empirical study at the company, trying to apply the existing tools there and then see whether the existing tools can already fulfill the requirements that developer have.
Okay, thank you. I have another question from Tayana, and she says, again, very interesting work. I'm starting to research the use of logs to assess the user experience at immersive events. And I know it's not your focus here, but I would love to hear if you have any thoughts about this.
User experience at immersive events. I'm not sure if I understand the concept here. Do you mean that the events that they got from collected from the user, like the user log?
I think so. I think
Okay.
Tayana can clarify maybe in the chat, but I think that's what she's talking about. So I think she's talking about immersive, as in the users are immersed in the experience, and there are logs, user logs that reflect the user's actions and activities.
Okay, yeah, the logs that reflect how user interact with the tools. Maybe, yeah. I think there are some study already exist in process mining. There they try to mine the process from the logs. For example, a user can be someone who interact with a bank system, and there they do some operation, and those events are logged in the file. And there, with process mining, they try to mine the process of how the user interact with the banking system, for example. Mm-hmm. Yeah, I think that that could be a very interesting fields to look into.
Okay. Yeah, so there's not really another question, but a little bit of a discussion in the chat about needing more empirical work with real developers. That's absolutely true. Something that's missing, that's hard to do. So kudos to you for carrying that out. You have someone who looks like they want to replicate your study with their industrial partners. Alexander's already made a connection, so that's great. And it looks like, yes, Tayana got her question answered as well. So we have just a few more seconds if anybody has a last question. There will be a discussion room that will pop up after this if anyone wants to talk about it more, especially Mauricio. If you want to replicate this, I would suggest you go to the discussion room and you can talk about it more with Alexander. And okay, a few more seconds. Anybody have a last question they want to sneak in? If not, thanks very much. And the next talk will be showing in 3, 2, 1.
Thank you.